Okay, today I'm going to talk about section 4.3, limitation on the linear cost model. Okay, let's come with the first example, lavender laundromat. The lavender laundromat is neighborhood laundromat. Lavender has 15 washing machines, 10 dryers, and handles about 100 customer per day. Okay, highlight this. So 100 customer. Didn't work. So 100 customer per day. The fixed cost to run the store are 65 per day. And so then I can put F equal to 65. Okay. This includes costs such as the rent, cleaning, and attendant, and the cost of electricity to power the line at the night. The per customer cost, which is variable cost, is 1.5. So I have V equal to 1.5. Okay, so this includes costs such as water to run a load of wash, electricity to power the washing machine, and dryer, and machine maintenance. Using linear cost model, the total daily cost to run the laundromat is, okay, so easily you should know that we're gonna use the function for the cost as F plus Vx, right? So that's gonna be 65 plus 1.5x. Okay. So then easily you can find the C of x, the cost, is the total daily cost in dollar for x customer, which is this equation. So then you can also find C of 100, which mean for 100 customer, it costs about 65 plus 1.5 times with, now exchange become 100. And so then it's gonna be equal to 150 plus 65 will give you 215. So 215. Okay, so then that's going to be amount cost for 100 customer. Now let's move down to the next page. I have lavender laundromat. I keep going with the equation above, and the question is what is the cost if 500 customer come in on Wednesday? Okay, so that means like 500. So for customer is 500. So then I just change it. 65 plus 1.5 times 500, right? Easy. So then it's gonna be equal to 815 $. So I'm gonna say the cost for finance customer coming on Wednesday is 815. Okay. The cost formula is telling us that the cost to serve or finance customer is 815, but that cannot be right. What is wrong here? It is capacity, right? You cannot have 500 customer in in one uh, in one laundromat. So I'm gonna say uh, laundromat. Um, laundromat cannot serve 500 customer in one day. So then you're gonna say not enough, not enough space, or you can say not enough machine. Okay, so now let's see. Now suppose the owner of Lavender can move to a larger space, which is next door, right? And buy more washer and dryer. The fixed cost now is changed, right? The fixed cost in larger space is now become 240 per month. So the new cost formula is given as I think the fixed cost for the large space in here is 240 per day, not per month. So this is like a typo, because why I know that is per day, because uh, for the small space at first it was 65 per day, which is actually, you know, is if you have like a last place but cheaper than cheaper price than a small space, that's impossible. And also you can see in here I think they mentioned this to be 240 per day. Okay, so then this is new fixed cost. I'm gonna say F1, okay, and the variable cost still gonna be the same. So I'm gonna say C1x gonna be F1 plus V V times X. So then now you're gonna substitute in. You have F1 equal to 240. You plus with V was 1.5. Okay. X, and that will be the new equation for you to use. Okay, so now then you can find for 100 customer for new place, and in daily cost gonna be CF1 equal to 240 plus 1.5 100 equal to 390, and then you can say summarize new daily cost for 100 customer is $390. Okay, but the thing in here is that if for the old store the daily cost for 100 customer it just was only 215. So the owner is actually losing some money, right? So you can say in order to compare, you're gonna say he losing 390 minus 215, which is 175 dollar. So losing is losing $175. So he need to get more customer into the new store. If he is, if he want to, if he want to increase his profit, right? The capacity in the larger space is, oh, it said like, oh, so the new capacity is just only 200 customer per day. Okay. All right, so let's see the next one. Next page, what do I have? Okay, so now let's go down. Okay, here is the piecewise function for the cost function of the lavender laundromat. You can see that the first one was old for the old cost or the old capacity. Old space is cost for old space. So we just help you for only capacities that's less than or equal to 100 and greater than or equal to 1 as a 0. And also for the next one is greater than 100 and less than or equal to 200. So it should. So that's the reason why it should go from here to here. It's actually, if you want to make it like to see like why you have like fixed cost at 240 here, you can see that if you that should be like the y-intercept of y-intercept of the new equation. Okay, so you can see that it's 240 here, but yeah, so this is new equation, so new space. Okay, all right, so you can see that there is difference between the first and the second. So now let's see down here. Okay, so on average, each customer spends $5 each time he comes to the laundromat. So the revenue function is Rx equal to 5 times X. So this, the dot line here is actually the function of Rx. And the piecewise function graph here is a function of 0x. So in order to find the profit, if there is 140 customer, okay, say 140 customer, you can have here 140 customer. So that's gonna be the profit, and you can say, do I have that? So draw an arrow showing the profit if there is 140 customer. Okay, so So here is the profit. Okay, and they say use a graph to estimate the profit from 140 customer in the large space. Yeah, in this case, I'm gonna say the distance was from okay, so I'm gonna write profit it's gonna be equal to revenues subtract for the cost. So you know that in here the revenues up here, I use other color. The revenue in here is it is around 700. So I put 700 and I minus for the cost, which is around 450. 450. So that we're gonna have 250 at the profit. So let's circle this. Okay, so let's see. So profit. So this is a way to estimate, but if you want to figure out exactly by using the equation, you can actually substitute for R of 140, and then you're gonna have the revenue in this equation. So it's 5 times 140. We're gonna give you for um, 700, right? 700. And for the cost at 140, I will use my cost function. I need to, maybe I'm gonna use smaller. So I know that cost function was in this case is fixed one was 240 plus 1.5x, right? So I substitute for C of 140 will be 240 plus 1.5 times 140. So that will give me 450. And that is exactly this one. And this one is exactly 700. So that is a reason why when you substitute in, you also want to have exactly 250 at the profit. Okay, so let's go down. Okay, so we're gonna estimate the profit from 200 customer in small space. And then the owner of the laundry want to make at least as much for profit in the large space as they did for 100 customer in the small space. How many customers needed to come to the large space for that to happen? Okay. So firstly, let's try to figure out what is profit from on a customer in a small space. So you're gonna use C of X for the first for the O space, for the small space gonna be 65 and plus 1.5 X. I may be gonna say small here and put over here is large. So you guys can know that the difference between two this. And also maybe I'm gonna say for X is from 0 to 100. Okay, so okay, so now you're gonna have C 100 will be equal to 65 plus 1.5 times 100 will equal to 215. Actually, when you take a look at the graph, because this is try to estimate by the graph, you can see that here should be 215, yes, around that. So let's go down. Okay, and now you know that for the revenue of 100 will be 5 times 100, which equal to 500, right? So the profit, what's the profit gonna be? Profit with P 100 will be equal to 500 minus 215, which P 100 will be equal to 285. So the question is, how many customers need to come to the last space to make the same profit at the small space? So this is the profit that we want to make. So now I'm gonna come to the profit function of the large space. So large space have profit as P of X will be equal to so 5x minus 240 plus with 1.5x. So you can know that this is the revenues, and it is the second piece of the cost function. So then you have distribution, you have 5x minus 240 minus 1.5x, and you will have P of x will be equal to 3.5x minus 240. And now I will substitute for, I want to have profit equal to 285, right? I want to have that profit amount. So I will plug in 285 equal to this equation, and then I will solve x by adding 240 both inside, and then I'm gonna have what? 3.5x equal to 240, right? Equal to 525. 525. And then you divide by 3.5 both inside, you will get x equal to 150. Okay, so 150. Let me just gonna circle this. So at least 150 customer need to come to the last page for so then we're gonna have the same profit. I mean, we're gonna have the profit as one of the customer come in a small space. Okay, so let's go down. So this is graphical view of same columns. Okay, so there is another way to look at the last column. We use the profit function. The profit for X customer when X greater than 100 is, so we need still use PX equal to revenues minus cost. So in here, revenue is for the case that's greater than 100 will be the same, and the less than or equal to 100 equal to 5x, and then minus for the C of x in here, we're gonna be C of x is gonna be in this case 240, and plus with 1.5x. 1.5x. So then easily you will have P of x will be equal to 5x, no, not 5x, as a bow function. I have 3.5x minus 240. That's going to be the function for x. A profit for x have to be greater than 100. I should also have to have less than or equal to 200. And for the k that x less than or equal to 100, then we still want to use px equal to 5x is the revenues minus, for now it's going to be the cost of the small place, which is 65 plus 1.5x. So then you're going to have 3.5x minus 65. So let me gonna circle this. So this is gonna be another function. So like the cost function, right? The profit function has two p's, or we call it piecewise function. Px gonna be 3.5 minus 5x minus 65 if x is in between 0. Oh, in between 0 and 100. Too many mistake from the guy notes. we actually like the first time teaching this course, so we need to improve a lot actually. All right, so now for the second pieces is in between 100 and 200. Use 3.5 minus 240, and this should be the graph of the profit down here. So the first one, the first one is for the let me see. Okay, so the first one is for small space, or both this is about p wax, is a function of p wax. So this is a large space, and the profit will be equal each other only the case as x equal to 100 for a small space and x equal to 150 for the larger space. So I'm gonna stop this session here, and we will have exam next week. So for today, I don't gonna let you do assignment 4.3, but your assignment for this session will be included into the review assignment. So please go ahead and do the review assignment. We also gonna be your checklist for the XYZ homework. So similar with doing another assignment, but for this assignment, you will have a chance to improve the score, and also you will have like enough material to handle the exam one. And I will see you next time, and good luck you guys on the exam one. Bye.